Good morning, ma'am. By the way, I am Angelo Di Climaco, and my co-members are Panhay, Virano, and Liket. So, allow us to present to you our recalcitrant, which is the germination response of Theobroma cacao seeds to storage temperature and duration in sun medium pots. So to begin with, Theobroma cacao, the scientific name for cacao, is a beautiful tropical plant that is widely recognized for its seeds, which are the main component used to make chocolate. Cacao is traditionally grown in loamy, well-drained soil that are high in organic matter. However, interest in substitute planting media, such sand, has increased due to worries about resource scarcity and soil degradation. Sand has a number of possible benefits. Its porous structure encourages drainage, lowering the risk of waterlogging, and in some areas, its affordability makes it a sensible choice. By concentrating on the combined effects of storage, temperature, and time, this study seeks to close the information gap regarding cacao seeds germination and early seedling development in sand. The goal of the study is to determine the best seed storage techniques for promoting successful germination and seedling establishment in sand by examining the germination response of seeds kept at room temperature and chilled for varied periods of time. In this exercise, we the students must learn how to germinate recalcitrant seeds, also learn how to evaluate percent germination type. Specifically, this experiment is carried out to evaluate the germination response of the broma cacao seeds to storage temperature and duration in sand medium pots, determine the recalcitrant seeds, and discuss the germination of recalcitrant seeds.
Good day everyone, my name is Chorito Likit Jr. I will discuss about materials and methods. So materials, number 1, recalcitrant seeds or cacao seeds. Number 2, pots, sand, roller, cell phone for documentation, ziplock, microwavable Tupperware. Procedure. Step 1, begin allocating recalcitrant seeds. Step 2, obtain the cacao seeds, soak them overnight, and extract them mucilage. Step 3, equip the ziplock bags and 3 microwavable Tupperware containers to save as medium for the seeds. Step 4, distribute 20 seeds into each designated medium. Step 5, place 3 ziplock bags with seeds inside a refrigerator and 3 microwavable containers on the top of the refrigerator, each labeled for day 7, 14, and 21 days. Step 6, prepare a 20 seeds for a planting in pots filled with sand for the control group, comprising 0 days. Plant 10 seeds per replication and conduct 2 replication. Step 7, following 7, 14, and 21 days, plant seed from both refrigerated and ambient treatments with 2 replication for each involving and 10 seeds per replication.
Good day everyone, my name is Jerry Pana and I'm going to discuss about our result and discussions of recalcitrant seed. In this activity, we have two factor in this activity, which is factor A is type of storage, which is composed of E1 refrigerated, E2 is ambient, and factor B is a storage duration, which is B1 we have 0 days control, B2 is 7 days storage duration, B3 is 14 days storage duration, B4 is 21 days of storage duration. And we have this activity, our date planting is November 8, 2023, and replication seeds is 10 so per replication, 10 seeds per replication. Then as you can see in table 1, in the emergence of recalcitrant seeds, in D9 the control group Group P1 initially showed 5 to 10 seed emergence. By day 16, an increase to 5 to 10 for replication 1 and 1 to 10 for replication 2 was noted. Chilling E1 B2 exhibited better results on day 23 with 3 3/10 for replication, replication 1, 1/10 for replication 2, compared to ambient storage E2B2 with 0 to 10, which is no germinations. In D23, control group P1 displayed an increase to 6/10 for replication 1, but replication 2 remained at 4/10, and E1B2 saw a slight rise to 2/10 for replication 2. However, A2B2 had minimal improvement to 1/10 for replication. In D30, control group V1 had no further emergence, which is 8/10 lang for replication 1 and 5/10 for replication 2. E1B2 showed no emergence for replication 1 but a minor increase to a 1/10 for replication 2. Surprisingly, E2B2 had 1/10 emergence for replication 2. In table 2, number of surge emerged. As you can see in the experiments into the influence of two factors, which is type of storage, and storage durations on emergence of cacao seeds. The replication 1 highlighted the optimal viability of cacao seeds in the control group B1, with 8 seeds emerging, while 5 seeds emerged under 7 days of refrigeration, and E1B2. Notably, the lowest emergence was observed in the E2B2 treatment, representing the ambient storage for 7 days, with only 1 seeds germinating. In replication 2, mirrored similar trends demonstrating reduced emergence in the control group B1 with 5 seeds emergence. The E1B2 treatment in this replication resulted in 2 seed emergence. Overall, the results suggested that refrigeration E1 might minimally affect seed emergence compared to ambient storage, A2, particularly evident when the storage duration extended to 7 days. These findings align with earlier studies indicating improved seed longevity in refrigerated storage compared to ambient conditions, potentially due to controlled environment maintaining seed quality and viability.
As the table 3% germination of cacao, the germination performance of cacao seed was assessed under different storage conditions and durations, with factors A and B representing the type of storage duration respectively. The result as presented in table 2 reveal noteworthy variation in seed germination across treatments. In the control B, where seeds were stored in ambient condition for 0 days, a high germination rate of 80% was observed in replication 1, while replication 2 exhibited a somewhat lower rate of 50%. This discrepancy could be attributed to natural variation in seed viability or environmental factors influencing germination. And for the A1B2 treatment, the germination rate were 50% replication and replication 2 with the effects of refrigeration, the A1, and the 7-day storage period, the B2, were examined. The total germination rate did drop relative to the control, but it did so less sharply than anticipated, indicating that cooling might have a modest impact on seed viability for a brief period of time. On the other hand, seeds kept in room temperature for 7 days, the A showed a significant decrease in germination, with rates in replication 1 and 2 of 10% and 10% respectively. This decline suggests that ambient storage, even for a brief period, negatively impacts seed viability compared to refrigeration. Notably, seed subjected to extended storage duration of 23 days, the B3, and 30 days for B4 under both ambient A1 and refrigerated A2 conditions should complete inhibition of germination in both replication. This suggests that prolonged storage adversely affects cacao seed viability irrespective of the storage environment. For the table 4, it shows the shoot and root length for the data cacao plants grown in sand medium under different treatments. The highest mean shoot length was observed in treatment B1 reaching 18.6 cm, while the lowest mean shoot length were recorded in treatment A2B2 with 10.5 cm and A1B2 with 14.2 cm. Interestingly, treatments A1B3, A2B3, A1B4 and A2B4 displayed no shoot or root growth. The root length followed a similar trend with treatment B1 exhibiting the longest mean root length of 9.1 cm. Treatments A1B2 and A2B2 displayed shorter root length of 7.2 cm and 6.3 cm, respectively, suggesting a potential correlation between shoot and root development. Notably, treatments A1B3, A2B3, A1B4, and A2B4 showed no detectable root growth. These results suggest that treatment B1 positively influenced both shoot and root development in cacao plants, indicating its potential role in enhancing overall plant growth in a sand medium. And for table 5, fresh and dry weight, the experimental results demonstrate notable variations in the fresh and dry weights of cacao plants grown in a sand medium under different treatment conditions. The control group, the B1, exhibited the highest mean fresh weight at 9.2 grams, accompanied by a considerable dry weight of 4.1 grams, suggesting robust growth and effective nutrient utilization. On the other hand, treatments in which certain nutrients A1B3, A2B3, A1B4, and A2B4 were absent caused the plants to completely stop growing as seen by the absence of fresh and dry waste. This highlights the non-negotiable contribution of these nutrients to overall plant health and productivity and emphasizes their critical function for cocoa growth in sand medium. Results of treatment combination combining A1 and A2 with B2 were in the middle. A1B2 showed a moderate response to the nutritional circumstances with a mean fresh weight of 7.5 grams and a mean by dry weight of 2.9 grams. In contrast, A2B2 showed a lower mean fresh weight of 4.2 grams and a lower mean dry weight of 1.9 grams, indicating a less beneficial effect on the growth of cacao than A1B2.
So in conclusion, the study found that the control group B1 had a significant impact on cacao seed emergence with consistent growth. Refrigeration E1 was found to be significantly more effective than ambient storage when comparing storage types. In terms of storage duration, the 7-day period was significantly more effective than 14 and 21 days. These results highlight the importance of storage conditions, with refrigeration and shorter duration being favorable for optimal seed emergence in cacao cultivation. Thus, the experiment suggests that B1 is more effective than refrigerated and ambient storage in promoting seed emergence. However, the experiment was conducted under specific conditions and with a limited sample size, so the results may not be generalizable to other situations. Further research is needed to confirm these findings and to explore other factors that may influence seed emergence. Moreover, the study suggests that further research could investigate the physiological mechanism behind these trends, providing deeper insights for agricultural practices. That's all. Thank you and advance Merry Christmas. And this is all our documentations.